Next, we have ARP. Now, ARP stands for Address Resolution Protocol. Address Resolution Protocol is how our computers find out which IP address is associated with which MAC address. So, our ARP files under the data link layer, the layer 2. But again, it's sort of like our layer 2.5 almost, because we're determining IP address to MAC address. Now, ARP is not going to assign MAC addresses to IP addresses. Like the IP part of our IP suite does do that. The IP part of our IP suite is what we use for assigning addresses, assigning logical addresses to physical addresses. Our DNS helps resolve those. ARP is just going to, or DNS is going to resolve fully qualified domain names to IP addresses, and ARP is going to resolve IP addresses to MAC addresses. So don't confuse DNS with ARP. DNS is if we were to, how we translate google.com to an IP address. ARP is how we translate an IP address to a network interface card address. Now that we know what IP address we're trying to send a packet to, ARP will let us know and helps us find out what specific network interface card we're sending a packet to. So it's not just enough that we know, okay, what logical address am I sending this packet to? I need to know exactly which cable and exactly which network interface card this packet goes to. ARP requests are used in order to form tables which allow us to map, they allow us to map ports to different MAC addresses. They allow us to send specific packets to specific MAC addresses. And ARP requests, if you're using a program such as Wireshark, which captures packets and digests those packets for you, protocol analyzer, protocol or packet capture software, you'll see requests that say there are ARP protocols, and they'll say something similar to, who is X, tell X. And those X's will be replaced by IP addresses. So ARP will say, who is 192.168.1.1? Tell 192.168.1.3. So you're essentially having a client and say 192.168.1.1. Say that's your default gateway, and one of your clients is saying, okay, I need to find out what MAC address this is. So I need you to tell me what MAC address 192.168.1.1 is, because that's my default gateway. I need to know what MAC address that is. I need to know where I need to point this to. ARP can also be a good way to see if someone's trying to do something like enumerating our network. If someone is trying to use a program on our computer to find different objects in our network and find out if something is running in our network and find out what our network topology looks like, they may be using ARP. ICMP requests, ping requests, are a bit bigger packets, and they're requesting echoes back. ARP requests aren't as big packets, and they're just sort of enumerating our network and looking around. So say we plug in our protocol analyzer, we plug in our Wireshark, and we see, whoa, I have like an ARP request for every single IP address in the 192.168.1 range, and they're just going sequentially. I have an ARP request for 192.168.1.1, 192.168.1.2, 192.168.1.3, and you have one particular client that's requesting the information for all of those IP addresses. That's not normal. If you're seeing all that additional ARP traffic on your network asking for all of the IP addresses in a range, then you might want to watch out. That may be an indicator that someone is trying to get ready to do something. They might be getting ready to do ARP poisoning. ARP poisoning is where we have one device that is about to masquerade as someone else and perform a man-in-the-middle attack, essentially. Where they're going to wait until they hear an ARP request. They're going to wait until they hear someone ask. So our device goes out and finds out, okay, I'm going to do an ARP request on all the devices in this range. Okay, this is everyone's default gateway, because this is the router. This is the router everybody's going through. The next time somebody asks, who the router is, I'm going to say it's me. So the next time someone says, who is 192.168.1.1, I'm going to say it's me. So now we have a computer, we have a victim client, and we have an attacker computer. Badly drawn attacker computer, but it's a beat up old attacker computer. And this attacker computer says, oh yeah, 192.168.1.1, that's me now. So whenever the victim computer is going to send data that it thinks it's sending to its default gateway, it's sending to its router, instead it's going to send that now to the attacking computer. Because that attacking computer has said, now I want you now to associate this IP address with my MAC address. This is used especially in, this wouldn't be as necessary in a hubbed environment, because a hub is going to send packets to everybody. It doesn't care. This is especially notable for a switched environment, where a switch is only going to send packets to who they belong to. And so this device is going to essentially start pulling those packets. So we're performing this man-in-the-middle attack. The victim is now sending all their packets to us. We're scanning them and reading them, and then we're passing them along to the router after we read them. So we can read those packets. We may be performing some other SSL stripping, or we may be doing things that are even more insidious than just scanning people's packets. But ARP is a very important protocol. And it's very important to keep an eye on your network and to keep an eye on different clients performing different ARP operations, because you don't want to run into a situation where you're having these man-in-the-middle attacks going on, and you want to be very careful with what's speaking out and answering these, who is X, tell X. Because all it takes is someone with a little bit of computer knowledge, or someone who has just a little bit of Googling and YouTube experience to say, oh, I can download this cool program that can do that can completely automate man-in-the-middle attacks for me. And then in 10 minutes they're up and running, and they're capturing packets on your network by performing a man-in-the-middle attack, all thanks to using address resolution protocol improperly. So that's our ICMP, IGMP, and ARP protocols. These are network and data link layer protocols that do not have associated port numbers, because we're not sending directly to a port number. So don't get these confused with our later protocols that do have port numbers, or run into a situation where if you're on a test and you see a question like, which of the following protocols is the default protocol for port 80, and ICMP, IGMP, and ARP are 3 out of the 4 answers. Well, you're in luck then, because that 4th answer should be HTTP and is going to be the right answer, because ICMP, IGMP, and ARP don't have protocols associated with, or don't have port numbers associated with them, but they are part of our TCP protocol suite.